Thank you, Christoph. First of all, would like to pick up on what you said. We are here already for 2 days. We already had 2 wonderful days here, very productive days. We had actually the working phase, have it behind us now with this meeting. And thanks to Christoph, Eleanor, your whole team for hosting us here. It's always a privilege and pleasure coming to Birthday. Picking up on what Mark said on IEA work, there are still some people in this space who are with this activity, daylighting, since decades. And we had been here, I think the last time was the lighting group like 20 years ago. We did task 21, task 31, and are very fortunate to have the chance to pick up on this and to collaborate here with LBNL. In this project as well. So I would now like to talk a little about the motivation of this task 70 Annex 90 called low carbon, high comfort integrated lighting. As you can tell from the title, we're trying to address quite a bit with this aspect. So it's on integrated view of things. So we're looking at electric lighting as well as Mark addressed quite a bit the facade aspect. We're trying to bring in the human perspective, comfort issues, and putting that under, I think, one of the major constraints we are all having nowadays on the focus of decarbonization. Just jumping in on what Mark said, IEA, talking a little about the background. It's the International Energy Agency. Main, I think, headquarters is in Paris. It had been founded in the early 70s after the first oil crisis by OECD countries. And you can see it here. I think that's a screenshot I took yesterday or 2 days ago. So from their main webpage, it is looking at the building sector specifically as well, and coordinating basically all energy-related aspects from nuclear power, fossil things, renewables, and then tracing the progress towards those global goals like the Paris Agreement. So that is basically what IEA is doing, consulting the member parties and member states, and then also sort of bringing together. Mark mentioned a couple of so-called technology collaboration programs, bringing together what the connection is to our group, researchers from all over the world, trying to coordinate on specific topics we're seeing. And we are with our lighting aspects here associated to the solar heating and cooling program on the one hand side, and are collaborating with this other TCP, which is called EBC, so Energy and Building and Community. So that is basically the sort of formal framework we are working in. And look here a little. So looking at it from a, let's say, a little higher altitude, when we are putting lighting into the context of these global goals we're having at the moment, we know that lighting accounts for around 5% of the global greenhouse gas emissions, that lighting is at around 15% of electrical energy consumption worldwide, and we're seeing quite some dynamic and pressure coming onto that. As we are seeing more and more text use, CO2 emissions, higher competition for electricity. So I think that's enough motivation to look closer at all these lighting aspects. What we have been doing so far in previous project was a quite strong focus on the energy side, being energy efficient in lighting. And we think that we sort of have to broaden the scope a little, that we also encompass embodied energy for electric lighting and daylighting technologies, that we look at more regional market aspects, and that we also, of course, go into the interaction with the other building trades. So we are, as said, trying to broaden a little our perspective here. Up to now, we had been quite a bit in the usage phase, but now we're trying to include the product state planning design and also looking at end-of-life issues with this project. So that's another motivation for us, is that things, quite complex processes we're seeing here, to make them come real, we need digital support there. And in an ideal world, we would have a digital twin, but we all know it's not there yet. So one of the other motivations is to work with this project and progress on digitalization aspects as well. So looking a little at the different sectors for electric lighting, we all know that we went through the transition on LED level. So that's basically performed, highly optimized, highly industrialized. The costs are down, and we think that in this field, nevertheless, there are still open questions on the luminaire level, getting away a little from the lamp level. So luminaire architectures, we are seeing direct integration into building components, making those systems from the embodied energy more efficient, and also looking at new task lighting concepts. On the daylighting side, already addressed earlier, lots of topics. So we can basically provide the same daylight functions nowadays with new technologies, for instance, micro-optics, reducing the need for or the mass of plastics in facades. We see quite some progress in electrochromic glazing, color addition getting better, and also solutions like vacuum glazing might be an alternative to more massive facade construction, which just need more glazing levels and just as they have more mass in the future. Another thing I learned here from Steve is quite a big push on the thin triple glazing you guys are trying to establish in the market. So all going, I think, into the same direction, reducing the masses in the facade for the same functionality. Also, lighting controls, bringing it all together, a big issue. Also here we learned quite a bit from Eleanor and Christoph the last days, that we are trying to integrate things better and also connecting an important aspect to the grid better. So another aspect, of course, the planning and design process. We know that what we do today will have a long-lasting impact. So facades stay in the building for, I don't know, 30, 40, 50 years. So the design of and layout of these solutions is important. Same applies for electric lighting. And we know that we have not ideal planning processes, over installations of electric lighting, that we here have to work on the design tools. There are some first approaches which try to make design tools more intuitive, more automatic. So this is, for instance, taken from a lighting design software where the design you are doing is energetically rated and it is put into a benchmark positioning against an optimized solution. So already giving indications where a good solution in the future can be and where you can optimize your design. So that is potentially being in the future totally automatically driven, making design processes better. We are having as well architectural and design constraints and user expectations. I think we all know that we have to sort of fight for the facade area. There are different, let's say, motivations. We can go for all glass facades. We can use it for building integrated PV. There's facade greening, or also the PV integration onto roofs. So it's basically a struggle for the facade area which is there, and how can we basically make best use of it. Other aspect also addressed in the project is the densification. We know that from, for instance, going to San Francisco from dense urban environments, how can we achieve that we have good daylight supply in these areas? So those are aspects to be addressed. And some discussions, at least in Europe, I don't know how it's in the US, is also to switch totally to electric lighting. Not only trying to get out the daylighting, saying electric lighting, LED is so efficient nowadays that we can basically serve the lighting needs only by LED lighting. So that is in the discussion, and we have to, I think, find arguments to cope with that. That all has to be then, of course, brought, and that's one of the focuses in the project as well, into the needs of what people actually need and require for performing good, for feeling comfortable in the buildings. So we hope that we can make a little contribution with our project, that on the whole process chain, we will be rather here on the green side, bringing down the whole perspective of the different components, effects, that we are more rather on this side than that we are on this side, by combining new technologies, by connecting it to grid parameters and having sort of an overall optimization in the end of this project. So looking a little at the digitalization aspects, we know that we are having breaks in the digital chain. Those are incompatibilities in data and algorithms and models. And over the years, I mentioned at the beginning, IEA work has been going on for a long time. We always added to some aspects of this, and we also have on the agenda some new components, at least adding to the digital chain in this project. Although knowing that we won't in the end have a complete digital chain, but we are trying to work a little on that. So the overall objective of our activity is to identify and support implementing the potentials of lighting, as said, integrated electric lighting, facade day lighting, passive solar, in the decarbonization on a global perspective, while sort of aligning the new integrative understanding of human light needs with digitalized lighting in building and building related, also urban scale. So quite broad scope, trying to sort of find the overall optimum serving the needs of students. We are organized in 4 bigger sub-projects. The subtask A is on scenario strategies, roadmaps for this decarbonization. Subtask B is focusing on the human aspects, visual and non-visual user requirements. We are having subtask C, which is dealing with digitized lighting solutions. Those are addressing technologies on the one hand side, but as well as the design tools. And subtask D is then on case studies, looking at the application out in the field of these concepts. Who's behind this activity? We are normally at this meeting at around 30 experts on site. Altogether, it's a network of, I think, like 50 or 60 persons we are having at the moment. So some are in these days always taking the chance to connect hybrid via video conference. We are recruiting this team from, I think, 15 countries at the moment. So it's quite big. Network we're seeing here, entities, I think like 20 or 21 from universities, from applied research institutes, and from companies from the industry as well. So that somehow gives us a good, practical feedback loop included in the project. So we're having an information plan. Of course, we have to deliver some results. Those will be reports. Those will be simple software tools. We will provide seminars and have workshops. And so coming slowly or fast to the end. And we already have some early information out, for instance, LED guideline. And we have a web page running where we will consequently, when the results are coming up, they're starting to come up, put up the publications. We had now 1/3 of the project time, so we're running through June 26th, so there's some time to go, but the first results are showing up, and just some hints. Look back, we just finished 2 years ago another project, and we find quite some publications on another project. This is Task 61, Solutions for Daylighting and Electric Lighting, on the webpage of SHC. Also, a special issue had been generated back then also technology position paper for decision makers trying to bring things pinpointed down has been published. Okay, so that's a brief insight into our background, into our motivation, and I would then leave the detailed explanations and background presentations on the subtask to the subtask coordinators who then directly jump in. Thank you.
Thank you very much.